Hey guys, it's Chris at Highline Guitars and welcome to another one of my YouTube guitar building videos. In this episode, I'm going to share with you another one of my homemade guitar building tools. In this case, it is a 20-inch long, 12-inch radius sanding block. And this is a tool that I will use to fine-tune the radius of a fretboard as well as to actually level the frets. And I made this from a slab of aluminum that's 3.5 inches wide, 1/2 inch thick, and 20 inches in length. Now, if you've been watching my channel for a while, you've probably seen me using my 30-inch long, 12-inch radius sanding block. And this works really well, I think, mainly for removing the tool marks on a fretboard. But I really wanted something that I was confident was going to be more accurate for actually leveling the frets. So I decided I would carve one on my CNC machine out of this slab of aluminum. And the end result would be a radius sanding beam that is far less prone to, some of the drawbacks to using wood, which is the absorption of moisture in the air, which can cause it to move, to twist or warp or bend, which is a possibility with a beam like this, although I still consider it to be fairly highly unlikely. But nevertheless, when it comes to leveling frets, I want guaranteed precision. So I can achieve that with a radius sanding block that's made out of aluminum. Now, if you look closely, you can see that the radius that I carved into this block is pretty accurate. So, and because it's aluminum, it's not going to warp or twist or bend or anything like that. It's always going to stay perfectly straight. And the way it works is pretty simple. I just take a length of double-sided sticky tape, place it right down the center. And then I'm using, this is 240 grit sandpaper. And I'll typically use a 240 grit when leveling stainless steel frets. If I'm doing nickel silver, I'll probably back off to more like a 320 or even a 400 grit. And for fretboards, if I'm just trying to clean up the surface of the fretboard, I'll probably use the 240 grit. I might even jump to 400 if the tool marks aren't too severe. Now, to fine-tune the radius of a fretboard, obviously I'd have to do that before the frets were installed. And in fact, it's better to do that even before the neck is installed into the body. But what I did was I attached this piece of scrap rosewood to the back of my radius beam. And I did that with epoxy. So what I can do is I can flip it over and then I can clamp it into my little portable workmate workbench and then flip the neck over to sand just the fretboard. And then once I've got the neck installed into the body with the frets, what I can do is just lay this right on top of my fretboard and then just gently slide it back and forth, just like so. And that will quickly level down the frets so that they're all the same height. And the beauty of this is this sanding block weighs about 4 pounds. So I don't have to put any downward force. I just set it on there and let its own weight do the work. And then just slide it back and forth. It's really a simple tool to use. Now let me explain how I made this tool. I made the radius sanding block by carving it on my X-Carve Pro CNC machine. And what I had to do was create a 3D model of this slab of aluminum. 1/2 inch thick, 3.5 inches wide, 20 inches long. Then I formed a 12-inch radius surface, and from there I exported my 3D model as an STL and then imported that into Meshcam. And once I was in Meshcam, I was able to set up the tool paths for carving the radius. There are two carving operations involved in forming the radius. The first is a rough cut, and that hogs out most of the aluminum, but it leaves a fairly rough surface. And to do that, I used a 1/4 inch diameter solid carbide 2-flute spiral upcut bit. And I set it for a feed rate of 60 inches per minute with a plunge rate of 10 inches per minute. And then I set the spindle speed at 12,000 RPM. Then for the step over, I set that to be 16% of the bit's diameter and a depth of cut of 0.0625 inches. I also set it so that it would leave 8/1000ths of an inch of material which would be removed during the finishing process. And speaking of the finishing process, I used the same bit, my 1/4 inch diameter solid carbide 2-flute spiral upcut bit. However, I changed my settings only with respect to the step over. Instead of doing a 16% step over like I did with the rough carve, I did a 6% step over. And then the depth of cut is based on the amount of material that I left when I did the rough carve, which was 8/1000ths of an inch. So it's doing a depth of carve that's about 8/1000ths of an inch deep, and then a step over of 6%. So the end result is a very smooth surface. Now, a lot of guys, when they carve aluminum, will use lubricant, and you can actually watch them dripping or spraying lubricant onto the surface that they're carving. And in some cases, they have machines that have lubrication systems that automatically feed lubricant to the surface where the bit is in contact with the material. However, I chose not to use any lubricant at all. And if I had this to do all over again, I still wouldn't use lubricant. I don't think it's necessary when all you're doing is just a very shallow surface carving. Now, I know you're probably wondering, why make a radius sanding block when you can buy them from numerous sources on the internet? StuMax sells them, Philadelphia Luthier Tools sells them, I think Luthier's Mercantile International sells them. And I know that you can find them on eBay, Amazon, and AliExpress as well. Well, for a 20-inch long beam, you're going to look at spending probably around $100. So I spent $14 for this slab of aluminum, and it took me about 10 minutes to set up the G-code files, and then another probably hour and a half to do the rough carve and the finish carve. So, you know, and then maybe 10 minutes to glue this strip of wood onto the back. So in the end, I think I saved quite a bit of money. And the beauty of it is, I can do any radius I want to. This is a 12-inch radius, but if I want to do 7.5 or 9-inch or 10-inch, you know, 14, 20, whatever, all I have to do is tweak my files and get a new piece of aluminum and carve another one. It's that simple. So I hope you found this video to be useful, and maybe it will inspire you, if you've got a CNC machine, to make your own fretboard fret leveling sanding beam. And if so, please give me a thumbs up. That always helps. If you want to show this channel support, head over to eguitarplans.com and purchase a plan for building a guitar or some of the other tools that I use for making guitars. Now, I don't have a plan for this one because it really doesn't need to be one. And even if you don't make the plan, just know that your purchase will help support this channel and keep me going. And if you don't want to purchase a plan and still would like to support the channel, I do sell some t-shirts. I've got a merch shelf down below, and if you can't see that, there's a link to the my t-shirt store down in the description below, so be sure to check it out. At any rate, until the next episode, take care, stay safe, and I'll see you soon.